This session I will explain this constant K high pass filter. It is 10th page. It is constant K high pass filter. Okay, so that may be any filter. 6 things that we have to analyze: nominal impedance, cutoff frequency, attenuation constant, phase constant, characteristic impedance, along with the design of filter. So here first thing, let me draw the T and pi type of high pass filters. So we know that it is a T type of network. So it is a T type of network. One dash, two dash. It is Z1 by 2. It is Z1 by 2. It is Z2. Next it is pi type of network. This one is pi type of network. This is pi type of network. So it is Z1 and it is 2Z2. It is 2Z2. It is 1 dash. It is 2 dash. Okay. Here we know that it is a T network. It is pi network. T network and pi network. In case of this constant K low pass filter, this series branches are inductors, shunt branches are capacitors. If you interchange these series and shunt branches, then you will get the high pass filter. Means if Z1 is equal to minus jXC and Z2 is equal to j omega L, then the filter is high pass filter. Here Z1 is equal to minus jXC, Z2 is equal to j omega L. Means how to write this? It is a capacitance. So this is capacitance. It is an inductance. It is a capacitance. So this is 1 dash, 2 dash. It is capacitance. It is series branches are capacitances, shunt branches are inductances in case of these high pass filters. So it is 1 dash, 2 dash. Okay. Now it is Z1 is equal to minus jXC, that is minus j divided by omega c. Z1 this one. Z2 is equal to j omega L, that is okay. Now Z1 by 2, I want to calculate Z1 by 2 here. Z1 by 2 is equal to minus j divided by 2 omega c, that is equal to minus j divided by omega into 2c. Means what I mean to say here is, if I divide this capacitance, it will become 2 times here. Here it is 2c, but in case of previous one, if I divide this, okay, if I multiply with 2 times, that will become c will become c by 2 in case of low pass filter. Okay, so it is Z1 by 2 is 2c. Anyway, it is Z2. Z is j omega L, so it is inductance L. Now it is 2Z2. So it is, if I multiply with the 2Z2 is equal to j omega L into 2L. So L will become 2L here. It is 2L. And capacitance Z1 is capacitance, that is capacitance C. So this is how we need to draw this T type and pi type, T type high pass filter and pi type high pass filter. So now after drawing this T and pi type of high pass filters, I need to calculate the 6 things, that is nominal impedance, which is represented with the letter of K, and this we know that K square is equal to Z1 Z2. This Z1, what is the value of Z1 here? Z1 is equal to, what is this? Minus J divided by omega C, and Z2 is equal to J omega L. Let us multiply this Z1 and Z2. It is minus J divided by omega C into J omega L. This omega and this omega will get cancelled here. J square is equal to minus 1. Minus 1 into minus 1 will become 1. It is L by C. So K is equal to, now it is square root of L by C. For a low pass filter also, the value of the nominal impedance or design impedance is K is equal to square root of L by C. For a high pass filter also, it is same. Next, after calculating this nominal impedance, let me calculate second one is cutoff frequency. Cutoff frequency. So this cutoff frequency, it is FC. So this cutoff frequency, I can get the expression for cutoff frequency by using these expressions that I already told you. Z1 by 4 Z2 is equal to 0 and Z1 by 4 Z2 is equal to minus 1. So Z1 by 4 Z2 is equal to 0. Let me calculate it. Z1 what is the value of Z1 here? It is minus J divided by omega C divided by 4 into J omega L is equal to 0, or Z1 is equal to 0. Directly it is Z1 is equal to 0, or from this also minus J divided by omega C is equal to 0. That is omega is equal to infinity. That is 1 by omega. From this 1 by omega C, omega is equal to 0. Omega is equal to 1 by 0. 1 by 0 is infinity. So F is equal to infinity. So it is one cutoff frequency. That means it allows the signals up to the frequency F is equal to infinity. F is equal to infinity. And this is another cutoff frequency. So that is Z1 is equal to minus 4 Z2. Z1 value is minus J divided by omega C minus 4 into Z2 value is J omega L. This is Z2. So if we calculate J and J, this minus and this minus will get cancelled here. So what I got here is omega square LC is equal to I think it is 1 by 4. Yeah. Omega square LC is equal to 1 by 4, and omega square is equal to 1 by 4 LC. So omega is equal to 1 by 2 root LC. Right. Since it is a cutoff frequency, it is represented with omega C. So omega C is equal to 1 by 2 root LC. And in case of FC, we know that omega C is equal to 2 pi FC. So FC is equal to omega C divided by 2 pi. So omega C is 1 by 2 root LC divided by 2 pi. So it is 1 by 4 pi root LC. This is cutoff frequency FC. Okay, so this is the expression for cutoff frequency for a high pass filter. So we need to remember this expression along with this expression for a high pass filter. For a low pass filter, FC is equal to 1 by pi root LC. For a low pass filter, FC is equal to 1 by 4 pi root LC. Right. So I got the expression for cutoff frequency. Next thing here is third one is attenuation constant. Attenuation constant. Third one, attenuation constant alpha, attenuation constant alpha. Okay, so the expression for attenuation constant in passband alpha is equal to 0. There is no attenuation, we know that. In stop band the expression for attenuation here is 2 cos h inverse, that is square root of modulus of z1 by 4 z2. This is the expression for attenuation constant in stop band. Okay, so z1 by 4 z2, need to calculate z1 by 4 z2. z1 is equal to minus j divided by omega c. 4 z2, 4 into z2 is equal to j omega l. So what is this here? This j and this j will get cancelled here. It is minus 1 by 4 into omega square lc, that is equal to minus 1 by omega square into 1 by 4 lc, that is equal to minus 1 by omega square into it is 2 into root lc whole square. Okay, is it okay? 1 by 4 omega square lc. Okay, so what is the cutoff frequency for omega c is equal to, just now I calculated the cutoff frequency for a high pass filter. Omega c is equal to 1 by 2 root lc. Yeah, so I can replace this one with minus 1 by omega square. It is f omega c is equal to 1 by 2 root lc, that is equal to, here this in place of 1 by 2 root lc I can replace this omega c, so it is omega c square, right? So finally z1 by 4 z2, this value is equal to minus omega cc square divided by omega square, that is equal to minus omega c by omega whole square, that is equal to minus 2 pi fc divided by 2 pi f whole square. So it is minus this 2 pi and this 2 pi minus fc divided by f whole square. But here it is a modulus here. Since it is a modulus, alpha is equal to 2 cos h inverse, it will become fc by f whole square root. This square root, this one will get cancelled here. The square and square root will get cancelled here. So alpha is equal to finally 2 cos h inverse of fc by f. So this is the expression for attenuation constant in stop band. It is in stop band. Next thing here, I need to draw the graph between alpha versus Cf. That means this attenuation constant versus frequency. So this is the frequency. It is the cutoff frequency Fc, and we know that this is alpha. So which is pass band and which is stop band? For a high pass filter, it allows the high frequency signals. That means from cutoff frequencies to infinity. We already found that expressions. There is that expression. So here, so this passes the signals from Fc to infinity. So it is pass band. And it is stop band. Now if you find this pass band, you find this this expression in stop band. In pass band, alpha is equal to 0. So in pass band, so in this alpha is equal to 0 in stop band, and in pass band alpha is equal to 2 cos h inverse of this one, 2 cos h inverse of fc by f here. Okay, So if you write the expression, if you draw the this if you draw this waveform for this alpha versus frequency from 0 to fc, then you will get the expression as, sorry, you will get the waveform here. This waveform will be like this. Okay, at f is equal to fc, at f is equal to fc, this cos h inverse of one value is 0. Anyway, we can't define the value of cos h inverse of 0 here. Sorry, f is equal to 0, it will become infinity. So this total alpha will become infinity here. So it will start from this one. So this is the waveform for alpha versus frequency. Alpha is nothing but attenuation constant. Next thing here is fourth one. Fourth one is phase constant. Let me find the phase constant here. Phase constant is phase constant. Phase constant is represented with the letter of beta. Right. In passband, alpha is equal to 0. It is having some expression beta is equal to 2 sine inverse of, what is that, square root of z1 by 4z2. Okay. In stop band, beta is equal to, okay, let me write this. Here in beta is equal to minus pi here. Why it is minus pi? That we can analyze from the expression. Is that attenuation constant? Okay. So first let me find this one first. So square root of z1 by 4z2, beta is equal to 2 sine inverse of z1 by 4z2 in passband. So we already found that square root of it is modulus. So square root of z1 by 4z2 value is minus fc by f whole square. It is modulus, so it is fc by f whole square. This square root will get cancelled here. So 2 sine inverse of f c by f. So you will get this one. If you write this square root and square will get cancelled here. So finally you got this expression. And if you draw the graph between beta versus frequency, this beta versus frequency will be, it is frequency, it is beta, it is cutoff frequency fc, it is beta versus f here. It is for a high pass filter, it is pass band, and it is stop band, now for a pass band, beta is equal to 2 sine inverse of fc by f, and for in stop band, it is beta is equal to plus pi. Okay, it is pi. So this expression will be this one is pi. Okay, so it is stop band, it is pi, and this one actually I'll get it is minus sign here. Why? Because it is minus 2 sine inverse of fc by f, because of for high pass filter, you remember like that, it is minus 2, it will be minus 2 sine inverse. So if it is minus 2 sine inverse, and it will start from, suppose if it is, this one is minus pi, it will like this. It will be, this waveform will be like this. For f is equal to fc, it is pi by 2. It is pi by 2, 2 will get cancelled, it will be minus pi. For f is equal to infinity, it will become sin inverse of 0. Sin inverse of 0 is 0, so something into 0 is 0, so it reaches to 0. This is the waveform. This is the waveform for this phase constant beta. Next thing here, it is this is 11th, I think so. It is 11th one. It is 11. Next 12th page. So I explained the phase constant is over. Next thing is characteristic impedance. Fifth one is characteristic impedance. Characteristic impedance Z0. So how to calculate this characteristic impedance Z0? So for T network, for pi network, for T network, the characteristic impedance Z0T is equal to, we already calculated as square root of, we found this expression Z1 square by 4 plus Z1 Z2, and if you take a common of Z1 Z2, it will become Z1 by 4 Z2 plus 1 here. So anyway, it is Z1 by Z2 is nothing but, sorry, Z1 Z2 is equal to K square, it is 1. We already calculated Z1 by 4 Z2. What is the value of Z1 by 4 Z2 for a high pass filter? It is Fc by F whole square. It is 1 minus Fc by F whole square. So I can write as K into square root of 1 minus Fc by F whole square. So Z0T is equal to K into square root of 1 minus Fc by F whole square. So it is the expression for this T type of high pass filter. Let's come to this for pi network. For pi network, Z0 pi is equal to square root of, sorry, what is that Z0 pi expression? Z0 pi is equal to Z1 Z2 by Z0 T. Z0 pi is equal to Z1 Z2 is nothing but K square, Z0 2 is nothing but K into square root of 1 minus Fc by F whole square. So this K and this square will get cancelled. Z0 pi is equal to, finally, this is the expression that you are going to get finally, minus Fc by Fc whole square. So it is the expression for characteristic impedance for a pi type of network. And if you draw the graph, between this frequency versus this frequency versus this Z0, F is equal to, okay, so it is a cutoff frequency Fc. Okay, suppose at F is equal to Fc, at F is equal, it is, we know that it is a pass band, it is a stop band, and this is pass band for high pass filter. At F is equal to Fc, what is the value of at F is equal to Fc, what is the value of Z0T here? 1 minus 1, that is 0. So Z0T will start from 0. And what about this Z0 pi? At F is equal to Fc, 1 minus 1 is 0, it is 0, it is infinity. So it will start from infinity. Is it okay? Now at F is equal to infinity, if F terminates to infinity, something divided by infinity, it is 0. 1 minus 0 k, so it is k, so this is k, it is considered as k. So this z naught t will terminates to, I think it is z naught t, yeah, yes, so it is z naught t will terminates to this k. What about this z naught pi? F is equal to infinity, it is 0, it is 0, 1 minus 0, it is 1, so it is also terminates to k. So this is z naught t will be like this and z naught pi will be like this. So this is the waveform for this characteristic impedance of this T type and pi type for a high pass filter. Next thing here is design of a filter. Sixth one is design, last one, design of a filter, design of a filter. So here we know that k is equal to square root of L by C, and cutoff frequency of C is equal to, for a high pass filter, 4 pi square root of LC. Right, now I need to find the values of L and C is here. So for that multiply k into FC. K into FC is equal to square root of L by C into 1 by 4 pi into square root of L into C, that is 1 by 4 pi C. So the value of capacitance here is 1 by 4 pi kFC. So this is the design. This is an important formulas. Okay, for a high pass filter, he will give the value of the design impedance along with the cutoff frequency. Need to be calculate the capacitance value, so that we can use that capacitance value in T or pi type of networks. Next thing here is L value. So multiply here k divided by FC. K divided by FC is equal to, it is square root of L by C divided by 1 by 4 pi into square root of LC. So k divided by FC is equal to, it is L 4 pi L, I think so. Anyway, it is square root of L by C into 4 pi into square root of LC. This square root C, this square root C, 4 pi L will become. So L value is equal to k divided by 4 pi into FC. So this is the value of, this L value. So need to be substituted in T type of networks or pi type of networks. So for a, it is for T type of network, it is high pass filter. This value of C has to be substituted. What is this? It is C, 2C, it is 2C, it will become 2C. For a high pass filter, it is 1 dash, it is 2 dash, it is L. And what is it is T type high pass filter. Next pi type. So in pi type, so it is L. This is the value L. Here need to be substituted. So here it is 2Z2. So it is 2 into L. It is also 2L, and it is C here. So this is pi type high pass filter. So in the design, in the problem, if he asked to draw the T type high pass filter or pi type high pass filter by giving the values of K and FC, we need to calculate the C value and L value first. Then we need to substitute the C and L values in these networks, so that the problem can be solved. So this is the complete information about this high pass filter. Next session I will explain the band pass filter along with the band stop filter also, and after that I will explain the problems and in these concepts. Okay, with this I will stop here.